All right, so I'll go over these last like 4 or 5 questions. When we get to next class and we learn negative exponents and how we can simplify those, this might be a little bit more sense to you. For now, I'm just going to just go through and talk about it in one specific way. So if I give you 4 minus 1 or 1 minus 4, both of those give us the exact same numeric like number, just different signs. So one of the things that we can think about with subtraction is regardless of the order that we subtract, 4 minus 1 or 1 minus 4, we're going to get the same number in return, just different signs. So when we look at this problem here, first off, we treat our coefficients as if they're just on their own. So I can forget that f and f to the 7th even exist. I can just do 6 divided by 2, and I know that that's equal to 3. So right away, those coefficients I know is going to give me 3 is my answer. But now I need to look at my variables. And we were learning, okay, we do our numerator, so our power, when it's not written, it's understood to be 1, and we do 1 minus 7, which is negative 6. But we haven't learned anything with a negative exponent yet. So right now what we can think about is, well, where do we have more f's or variables to begin with? We have more in our denominator. So that means my answer is going to have to be in my denominator, because if I had x squared over x to the 5th, well, when I expand these out and start to simplify and cancel out, I see that I'm canceling everything in my numerator, but that's leaving 3 x's in my denominator. So since there's more x's in my denominator, that means that my answer is going to end up in my denominator. So here, like I said, it doesn't matter if we do 1 minus 7 or 7 minus 1, it's going to still give us the 6 in return. So we can just think about, okay, I have more in my denominator, so I can do 7 minus 1, and that's going to give me 6. So my answer has to remain in my denominator. Let me go through a couple more questions with you for this. And like I said, once we do go over negative exponents, I still always teach, though, where is there more, and that's where we end up. But once we learn negative exponents on Thursday, you can always do your numerator minus your denominator and then go from there. All right, this one's very similar to the last one. So I'm going to first just focus on my coefficients first. And 9 divided by 3, I know is going to give me 3 in my numerator. Now I'm going to move on to my variables. And I say, okay, well, they're both the same, so I know they're like bases. This is a power of 1. So I ask myself, where is there more at? And since there's more m's in my denominator, when I cancel these out, I know that that means that there's going to be m's left over in my denominator because there's not enough in the numerator to completely cancel. So I know I had to end up here. So I can look at my powers and say, all right, well, 4 minus 1 is equal to 3. So that means if I were to cancel them out, I'd only be able to cancel out 1m, and I'm going to have 3 left over there. Because we can think about this as 9m over 3m, m. We can expand that out. Well, I know that this 3 and this 9 are going to reduce to give me a 3. And this m is going to only cancel out and give it to one of those m's. So I have 3 left over in my denominator, which is m cubed. Like I said, when we go over this on Thursday of negative exponents, it should hopefully make a little bit more sense to you, but or that you can always just use the same steps and procedures. But this hopefully should make sense as to why it has to end up in our denominator. All right, and the same thing with this one. Treat our coefficients first. Well, 4 over 4, I know that they are just going to completely cancel out and give me 1. So right now, I don't know what I have anywhere in my fraction. So I'm just going to write my fraction bar. I look and see, okay, well, I have more n's in my denominator, so I know that n is going to end up there. If I were to expand this out, I have 4 n's in my numerator and 5 n's in my denominator. So when these cancel, I have 1 left in my denominator. I don't have to write to a power of 1 because it's understood to be that. And since we know that 4 over 4 reduces to 1, and when we cancel these out, we said that n over n will also be equal to 1. So what we need to make sure we do is we need to make sure we write that 1 in that numerator. If you just wrote n does not equal 1 over n, and if you just wrote 0, well, 0 divided by anything is equal to 0, so it's not 1 over n. So when everything cancels out in our numerator, we need to make sure that we write 1 in our numerator because that's what it simplified to. Like we could write 4 over 4 as 1 over 1. So 4 over 4n is equal to 1 over n. All right, so for this one, if I gave you x to the 4th over x to the 8th, well, same thing. Where do we have more at? We have more in our denominator, so I know it's going to end up in my denominator. And then 8 minus 4 is going to give me 4. So I know I'm going to have 4 left over here. And as I said, if we were to expand this out, when we cancel these, even though everything gets canceled, remember that is actually a 1. So we have to make sure that we remember to write 1 over x to the 4th. And x represents a number. X can represent any number that we want. So if I said x is equal to 887, well, that will bring us back to this original problem that we had of 887 over 4. So from here, since I had more in my denominator, I know it's going to end up in my denominator. 8 minus 4 gives me 4. So I'm going to be left with a power of 4. And as we talked about here, when we cancel everything out, we're still left with 1 in our numerator. So it'll be 1 over 887 to the 4th power. All right, so that's it for this one. And like I said, once we go over the negative, you'll start to see that it doesn't matter which way you do it. You can always just do numerator minus denominator. But for now, since we don't know what negative powers are, I'm explaining it this way to you. And then even when we do learn negatives, you're going to always hear me say, where do we have more? That's where it ends.